Welcome to Cloud Coffee and Certs, the podcast where we chat about cloud certifications, learning cloud skills, and staying confident on the tech journey. Grab your coffee, relax, and let's level up together.
Hey everyone, welcome to another episode. It's been a while, right? Well, I was hiking somewhere in Wales in my Easter break, and while I couldn't record anything, I was doing a lot of reading. So, of course, there's amazing content in today's episode around AWS networking while we are nearing to our certification date, and a good news around password spraying, which is somewhere related to what's happening in the political world as well, with the war ongoing between different countries, and of course high stakes around the impact on the global economy. Around that, there is some cyber attacks which of course are reported. I mean, cyber attacks, they used to be there even when countries were not in war, and now because of this war situation, there is higher number of attacks being reported in both sides, and we'll be discussing one such incident which was reported. I think it was last week only. So yep, another episode with amazing content. And before we move into our segment for news, let's take a quick short introduction break.
Let's hit pause on everything else for a moment and look at what's changing in the world of cloud and security lately.
All right, welcome back to the show. Now, in today's episode, like I mentioned, we'll be talking about a cyber campaign that actually didn't rely on any zero-day exploits this time, or even malware or any sort of like cutting-edge hacking tools, but instead it's something much simpler than that, and it is nothing but weak passwords. So, researchers recently identified a password spraying campaign that is linked to Iranian threat actors, or as our fellow Americans call, Iran's threat actors. And what those threat actors were trying to do was they were trying to target hundreds of organizations that are particularly linked to government and infrastructure related sectors. While the activity was concentrated mainly in parts of Middle East, similar techniques are regularly seen across different countries, including like Europe, US, and even UK. So let's discuss further on what really happened. I mean, in this campaign, the target was cloud-based businesses on environments which specifically around corporate email systems. More than 300 organizations are reportedly targeted during multiple waves of activities spread across March. Attackers didn't just hit once and disappear, they are like coming back again and again, adjusting their strategies as they learn more. So the type of organizations targeted weren't random. They were actually the government entities, or maybe companies which are directly or indirectly related to energy and technological sectors, and sort of what we call critical infrastructure, which are really high value and which have larger impact if you really attack them and you exfiltrate that out of those companies. That's why let's discuss about this technique as well, because like I mentioned in the introduction, it's simpler than other highly advanced tools which we normally are accustomed to see in our day-to-day cyber work. Now this technique is password spraying, which is different than brute force attacks because it's relatively simpler and smarter. Because in a brute force attack, attackers tries many passwords against a single account, and it's easy to report them, easy to block them as well, because you can have some sort of like controls around how many password attempt after how many password attempts you lock the account. So they get like usually blocked pretty quickly. Password spraying flips the idea, because instead of trying many passwords on one account, attackers just try one common password across many accounts. So things like I don't know, welcome 123 or company name 2024 or password underscore 123. These are simple password, and I've seen, to be honest, people using them even in production environment. And what this password spraying does is it's simply try these different commonly used password across multiple accounts. So it's slow, it's quiet, and it avoids any triggering lockdown lockout protections as well, because attackers tries once to one account, moves to another account with the same password, and go on and on until it like finally gets into one access to one real account. And that's the whole scenario in this case. And how this attack really work out, let's discuss something around that, because in this case it's familiar pattern which we see all the time. First, attackers attempted login requests from anonymous network, often using like infrastructure design to hide their true location. So you can use like those Tor browsers which have multiple layers of IP addresses, and no one can track from where the request originally started. And they test common passwords across many users, not thousands of attempts, just one or two per account. So it's eventually waiting for one account or one password which works. And once you gain access to maybe their email account, they get access to mailbox, they can get access to sensitive communication, internal documentation, contacts, workflows. So it's like you get access to potentially sensitive information stored within those accounts. And with OneDrive and password cloud based database also these days using the same single sign on accounts for accessing multiple applications in your infrastructure, it actually uh, multifolds the risks from losing one access. And if we think from that perspective, it's like I mentioned, it's not sophisticated exploit, it's not kind of like a rare vulnerability, it's not an advanced malware. It's just weak password, cloud login access, and just wait for it to do its magic. And what we learn from it, well, first and biggest lesson, multi-factor authentication, because MFA is one of the most effective defense against password spraying. So even if you lose your if someone gains access to your account, it should prompt for another authentication factor, which of course your attacker won't be knowing, because they don't have access to your maybe phone approval or maybe your hardcore tokens. So multi-factor authentication is one of the first and biggest lesson which we learn, that we should enable across all our accounts. And of course monitoring the authentication patterns as well. So maybe originating country, any small, even if there is a small login failure, it should be recorded and logged. And there should be some sort of like pattern detection as well. And in this case, I mean, AI comes and play a big role, because for human monitoring system on your SOC and SIM, it won't be it will be hard to detect. I mean, we can be honest about it. So if you use AI tools, then of course it's easy to flag all these anomalies in your logging. And if there's any sort of unfamiliar pattern, then it should be reported and logged right away. We should of course encourage strong password hygiene. I mean, there's no brainer in that. Unique passwords, long password, use password managers to create and remember your password. Don't just be lazy and just create those easy to remember password just for your own sake. But of course it's creating a bigger risk in terms of your organization's security paradigm. All these factors, I mean, they all these password spraying techniques, they make us creating a quick mental checklist where we should have MFA, where we should monitor our login activities, and we of course have better password practices across the organization. I mean, it's not something which is highly flashy, but it's the easiest way to block these kind of attacks. And we also have to remember that identity is the new parameter. Of course, our topic for today and as part of this certification is network security, which I still feel is highly underrated, because although this attack which we are talking today in today's news section again determine that identity is actually the new parameter for your cloud-based infrastructure, but network security is important as well. So we should have defense in depth. I mean, that's the crux of it. I never say that if we secure everything on network, then identity is not important. Other way around as well, if you have good identity protection, doesn't mean that you just keep everything open on your network. So we should have all those multiple layers in our defense. But yeah, I mean, that's the news. It's around politics, it's around the war situation we have. And I, like you guys, is hoping that this should be over soon and we should be having back to normal. But somewhere I was reading a quote that from somewhere between 60s to around 80s or 90s, you should say, those 30-40 years were actually the most peaceful time we had in our whole human history. So it's sort of in our blood to have these wars and fight. But of course, that's the good thing about history, right? We should learn our lesson from history and we shouldn't repeat those mistakes. So even if we are genetically in our DNA, we have war and fights ingrained in us, doesn't mean that we should continue to do that. And we should be improving ourselves. We should be changing with time because, to be honest, no one wants this. We have to get on with other challenges in life, and that's what common people like you and me want. But anyways, let's keep politics aside from today's episode, and let's move to our main segment where we will be covering global accelerators.
Let's level up, refill coffees, and dive into the main episode.
All right, welcome back. So, in last episode, we already covered some design patterns around CloudFront. Today's episode is around AWS Global Accelerator. So, we will start with basics and then we'll discuss about some of the design patterns around AWS Global Accelerator. And one of the key thing, how it differs from CloudFront, because I'm not sure about you guys. Maybe you guys are more intelligent than me, but my tiny little brain was really confused between why we have Global Accelerator and why we have CloudFront. Like, what's the difference between two? Because from the basics, they both look kind of like doing the same thing. But as I went into details, they are serving a different purpose. But of course, we should be pretty much clear on what solution to use at what point. And that's why in end of the episode, I'll do a quick sort of like comparison between CloudFront and Global Accelerator. And if time permits, because we are sort of delayed in our episodes by a week or two, so I will try to cover Route 53 as well, or at least I give a starter to Route 53 because we really should be covering more topics now. All right, let's start with Global Accelerator first. So, how can I put it? So, if I got an application running in maybe one or two AWS regions and my users are all over the world, like different locations, those users can send requests to my app. Traffic travels over the internet, and because it's public internet, it's unpredictable, it can be congested, it can have weird routing sometimes, and it's fine for a lot of things. But when you need consistently low latency, especially if your application is like sort of processing the real time data, or it's kind of like a banking transactional application, it's not ideal. So what Global Accelerator does is it intercept the traffic as close to the user as possible, and it route it onto AWS owns private global network instead. So you are not using public internet, you are actually traversing on AWS private network now, and it will be reaching to your end application. This is sort of like a basic core idea of why we are having Global Accelerator. Now, one thing to point out is app, shorter time duration, near the users, it's something what we discuss in CloudFront as well, right? So that's why confusion starts from here itself. Like, what's the point of having this when we have CloudFront? So let's cover it as part of this design pattern first, and let's sort it out, like why we have CloudFront and why we have Global Accelerator. Let's talk about the capability first. Global Accelerator, it have points of presence in mm, around 100 cities across different countries, and we are talking about like real edge locations. So it's like real cities, maybe Nairobi, Muscat, or Mumbai, Helsinki. It's generally global service, And it's almost certainly that where your users are, you will find an AWS edge locations nearby, so you can pick the traffic locally from your users to that edge location. Some of the features which are really nice actually for of global accelerators, let's start with static IP address, which sounds pretty like, yeah, so what, there's a static IP address, but it really solves some of the real good problems. Now, for example, if you expose an application to internet, you are dealing with DNS, and DNS have its own propagation. You have to update the records. You have to make sure that when something goes wrong in one part of location, then traffic switches from traffic failovers quickly from your one infrastructure to another infrastructure, and everything relies on DNS records. What Global Accelerator does is it gives you two static IP addresses that belong to your accelerator for this entire life cycle. So these IPs are anycast. I mean, they are announced simultaneously to multiple edge locations around the world. So when routing happens, it happens on network layer, not the DNS layer. So you are not relying on DNS now. You just have to make sure that traffic is routed to this particular IP address. So which practically means is IP your clients connect to never changes. You are not now relying on DNS name resolution. You are actually relying on that IP address, which is dedicated to you. So you can completely swap out your backend infrastructure, move from EC2 to a load balancer. You can change the reasons, endpoint, everything in backend, and client doesn't have to do anything because ultimately they are connecting directly with an IP address, and it work completely fine. I mean, for large enterprises where client side configuration is critical, and there are a lot of change management processes when IPs change, this really helps because now you have static IPs. Another important feature which is heavily used in design pattern for global accelerator is TCP termination at the edge. So normally when user connects to your application, they perform a TCP handshake. It's a three-way message. You have sync acknowledge, and acknowledge. So if a user is in Sydney and your app is in maybe US, then those three messages are then traveling across the Pacific, and you had to do it. I mean, you cannot just stop using TCP because ultimately it's the secure and better protocol than using UDP. So what Global Accelerator does is it let you terminate the TCP connection at the edge location as well. So because you are now connecting to the edge location, the handshake is happening locally, and because it's happening locally, it's faster, of course. Post handshake, your edge location is then connecting to your actual endpoint on AWS backbone, so you don't have to worry about further further connections, further terminations. You don't have to worry about what sort of protocol is being flowing there, because actual handshake happened at the edge, and once that's complete, all your user have to is just wait for response to come back from your main application in US, and that's why it's faster again, because TCP termination is happening at the edge. Now from here you can understand slightly the difference between CloudFront and Global Accelerator, because in Global Accelerator we are still sending requests or you know we are still sending uh, any sort of payload from main application. We are requesting from main application, which is in your core infrastructure. In case of CloudFront, caching was happening locally as well. So it's not like only you are terminating the request locally, like you are sending the request locally. Even the cache data was at the edge location as well. But because Global Accelerator is only for improving your networking side of things, it still have to send the request back to main or core infrastructure. But because it's going on a private network, it's fast. Now, another design pattern which is provided by Global Accelerators feature is custom routing accelerator, which is sort of a smart load balancer. So it figures out the best healthy endpoint and the sends the traffic there, which is again great for most workloads. So it flips the model. Now your application logic decide exactly which EC2 instance a specific user goes to. And why does it matter? Because for example, for gaming application, your server has done the work to determine a player A and player B should land on which gaming server, maybe in US1. And standard load balancing is useless in this case because they will just send traffic to whichever they think it's best to serve that traffic, and completely ignores the matchmaking logic. But with custom routing accelerator, you can specify ports on your accelerator to specific EC2 private IPs, and your matchmaking server then say like these two players should go to that EC2, and global accelerator execute that routing without any further manual interventions or without any further logic, which of course enhances the performance benefits for the AWS backbone. And that's why one of the use case for global accelerator is your applications which are around gaming or which are around maybe ad tech platforms where a class of students they all need to reach or land on a same server instance because maybe their lab is running there, or maybe video conferencing infrastructure. All these simple but highly important use cases are covered using global accelerator. While for CloudFront, if you recall, it was mainly for streaming applications, so it's differs there as well. Now, how it improves security? I mean, that's what we want to hear more about, right? So let's discuss something about security because AWS Shield is included with Global Accelerator by default. So you get always on network flow monitoring, you get automated inline DDoS mitigation without any extra configuration. I mean, this was something provided by CloudFront as well, but this is again provided by Global Accelerator as well. So you are getting your security at the edge. You want to absorb and neutralize any attack traffic before it reach your actual infrastructure. It should be mitigated on the edge location. That's how security at edge is provided by Global Accelerator. And if you are, for example, running a high value target like your financial application, critical infrastructure, it won't reach to your core infrastructure. So you don't have to worry about even attack to those application, but also you don't have to worry about any additional service to mitigate this, because this is something which is part of your application, your global accelerator service. So you don't have to pay additional bill for that. So that's another good thing, right? So in summary, global accelerator is for anyone which have distributed users across multiple geographies, and if you care about latency, reliability, or maybe both, like gaming companies, SaaS platform, e-commerce, then you have to use it. I mean, when I was reading about it, one of the use case or case study is around booking.com. They use this Sky scanners application for booking your airline flights. They use this service as well. So that's why it's one of pretty highly used application, and it's really useful to know when we are talking about AWS networking and networking at edge. Let's quickly discuss about the difference between Global Accelerator and CloudFront, because both services can be used to improve latency for your application, and that's why it gets confusing sometimes. But it's about cacheable content. So CloudFront provides caching. It does TCP connection at the edge. It gives edge proximity, but it's provide caching as well. Global Accelerator is better fit when we are only concerned about routing and failover, and we are not interested in advanced caching related use cases. So if you have a static caching related requirement for handling your web traffic, we can use CloudFront. If your requirement is just around non-HTTP workload, but you want a stateful dynamic connection which can be failover without much efforts, then simple use case, use Global Accelerator. Another thing is CloudFront still rely on DNS because it gives you DNS hostname if you recall, but Global Accelerator provide you static IPs. So static IP, if your requirement is that you want static IP addresses, you can get from your CloudFront service, because CloudFront deals with DNS based failovers, while Global Accelerator can provide you static IP addresses as well. So that's the difference between CloudFront and Global Accelerator. And after this, we have sort of finished discussion around Global Accelerator and CloudFront and networking at the edge. Let's quickly touch upon Route 53 as well before we finish today's episode, because I really want to get on with Route 53 today. DNS as a protocol, it's just domain name systems. It's as simple as having a record of your IP addresses and map it with your domain names. So if you have, we were talking about booking.com. So booking.com might be having some IP addresses in the backend. All you need to care about when you're accessing this website is you type in booking.com. It will be having 5 or 6 IP addresses, maybe in the back end of their application, or maybe load balancers. Your traffic will be routed to those load balancer IP addresses based on what you wrote in the domain name. And where this resolution happen, it's on the DNS. So your DNS will then determine which particular domain belongs to which IP addresses, or other way around as well, which IP address belongs to which domain name. So that's what domain name system is, DNS is. And AWS have this service called Amazon Route 53, which have Amazon's scalable DNS managed services. So you don't have to set up your own custom DNS on EC2 instance or on your infrastructure. You can use Amazon Route 53, which is AWS managed DNS. What Amazon Route 53 have as part of this, just like any DNS, it have DNS records, it have time to leave feature, it provides security. But of course, because it's AWS managed service, so it provide you something which is more than that, and uh, for different use cases. So we will discuss some use cases and design patterns around those as well. But let's talk about DNS records first. DNS records are the actual instructions which are stored inside your DNS. So you can call it as a configuration of your DNS as well. It's kind of the phone book where you have name and the number. So it's something similar in DNS as well, where you have domain name and you have IP addresses. So let's talk about these records. Each record type have its own specific purpose. So let's go through like some of the common ones today, and we'll discuss more about design patterns in the next week episode. One of the commonly used record is a record, which just map your domain name to your IPv4 address. So if your IP is like 192.0.2.1, that's your IP address. And it can point to a domain, which can be your EC2 instance, which can be your application load balancer, or which can be another IP address as well. So this is what a record does. It create a static mapping between your website, which is deployed maybe on AWS or anywhere on your on-prem infra, and it point your domain to a specific IPv4 IP address. So when someone types in that domain name, they will be resolved to that IP address, and of course that IP address will be then belonging to your one of your server, and traffic will be routed accordingly. So that's the part of a record. We also have a record, which is like four A's wrote together. And because it's slightly longer than a record, you can sort of map it to a slightly longer IPv4 IP address, which is IPv6. So this type of record is when your domain name is then mapped to IPv6 address. So that's just longer A record because you have longer IP address. So that's what these two records are. We also have CNAME record, which is alias to another name. So it's domain name to domain name mapping, which is really important when you are having sort of like multiple backend application load balancers and you want to map your domain with these multiple load balancers or these multiple domain names. So you can, instead of using like IP address for each server or each application, you can then have domain name to domain name mapping, which is CNAME. So it's another good use case of pointing your one domain to another domain belonging to different AWS services. And this is something which we also use in, for example, in CloudFront, because CloudFront provide its own custom domain name. So what we can do is we can map our public facing domain name with this CloudFront's domain name, and then all the traffic which is been targeted to my website IP address, website domain name, will be then forwarded and resolved and forwarded to my CloudFront domain name. So that's a good use case of having these alias records, also called like CNAME records. Another two pretty important records are MX record, which are specifically used for mail routing, and MX records tells email systems where to deliver your email. So for example, you have like technocoffee.com, and then your mail server is running on mail.technocoffee.com. So your traffic which is used for mail routing will be then resolved to this mail server. And of course, AWS have its own email service as well, which is Amazon Simple Email Service, Amazon SES. So it's really important in terms of one of the use case of using that service when you are trying to use Route 53 and that service. So that service will have its own MX domain name, MX server name, and you can map it to your domain name as well. So that's for MX record, which is specifically for mail routing. And last is TXT records, which is for metadata verification. So it stores your text data. So for example, if you want to prove your domain ownership, if you want to have email authentication like SPF or DKIM, if you want to have security policies, you can have this TXT record as well. And I also use it for my domain name verification. So I have to put in my domain name, and then I have to put some sort of text which then proves that this domain belongs to this user. So technocoffee.com belongs to me. And that's how I prove my domain name ownership to public DNSs. So anyone who then try to access technocoffee.com is routed to my website. So that's really important in terms of like metadata and verification, and that's the whole purpose of TXT record as well. So now we have covered all the records which we can create in our DNS service. Next week episode, we will be talking about DNS zones, specifically public and private hosted zones in Route 53, and different design patterns around using DNS in production environment. So that's it for today's episode, and let's catch up in the next episode with amazing content around AWS networking. Goodbye and good luck.
Been listening to Cloud, Coffee and Certs. Thanks for tuning in. Don't forget to follow and share if you enjoyed this episode. Until next time, keep learning and keep growing.